Hi guys, welcome to my channel. So today let's solve yet another leak code question. The description of today's question is fairly simple that we were given a non-negative integer number and we need to convert it into English words representation. Got it. So let's consider the first example 1, 2, 3 and 1, 2, 3 we will just call in English as 123, right? And great. And followed by 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, how will we call it? We have two options. Either we'll call 12,345. 12,345. Right, got it. And uh, nice. And also for 2, 3, 4, 5, we could either call it 1,345 or 2,345. Let me check out what they are calling 2, 3, 4, 5. Yeah? Maybe they'll probably call it as 1,345. I'm not sure. It's 2,000. Yes, 2,345. Got it. So we need to process this, and for achieving the result, you knew we were aware that one will be called as 1, 2 as PWO2, 3 as PHRE3 for us, but how would we specify this to a compiler by storing it at some position? So what I'll do is I'll just have a vector where I'll be having a pair having int along with string. So what this vector will be storing is vector of pairs, right? So first you knew that pair is combination of two elements where we'll be having first element and the second element. So our pair consists of first value as an integer followed by string. So ultimately we'll be having something of this kind. So something of this kind, one will be 1, 2 being 2, 3 being 3. But we'll store them in the reverse order starting from 1 billion because 1 billion would be the maximum value. Why will start from the leftmost, or why will start from the highest number is simple. The reason would be very simple. So if given a number is 2, 3, 4, 5, we would process it from left to right or from right to left. Every time we need to spell or we need to say that in words, we'll process it from left to right, right? So if we process it from left to right, we always need to start from the highest number, not the lowest number. If we started from the lowest number, then it would be 5, starting with 5, but we'll always start from the highest number. So here also in map, I'll store from the highest number only. And which details needs to be stored from 1 to 9. I'll compiler I mean doesn't know anything, so we need to store every data from 1 to 9. Similarly from 10 to 19 as well, because every time like we'll call 16, 17 or 13, they aren't of unique kind because 13 has a prefix third and 17 has 7, 16 6, 18 and 15. So that's not unique across all numbers from 11 to 19, so we need to decide them as well, and followed by all 10 multiples till 90. Those are also not unique, right? 10, 20, 30. You need to store them so that you can tell the compiler that values are defined already. So for that, I'll just use a map, and in my map, I'll just have a pair of. So first is 1 billion. So just let me check out if everything is working fine or not. Just need to- Probably we may not need it. So just let me try checking for this, and we probably need to get 1 billion for that. That's 10 million. So there will be one more zero over here, followed by million would be having two zeros lesser. So it will be 1 million. Why do I need one to store here? I do not need one to store here because that will be already computed in the prefix. And 1000. So I'm just storing these values to tell my compiler that if you find any instance of this, then it will be already defined as follows. So if I just check, verify these as well, if it's working fine, then we could proceed further. It should ideally be 1 million. So let's just check it out. I'm sorry for this. Yes, fine. So we are processed till 1 million. This would be 100 followed by 90 followed by I'm storing all these values to tell my compiler. Okay, got it. 80. We are here now 20, and now let's start from 19 to 11. 18. Right, got it. So just we define everything that we knew in English, and we wanted to specify our compiler that if you found this value, then this is the corresponding mapping in English word. So that's fine of it. Let's just add our recursive logic here as well. So why would we need a recursive logic for this? Answer here would be very simple. So if I just found out this thing, one number as 1 2 1 2, then how would it be 12 1200 12. So you just found this, right? We just processed this separately and we just mapped it to after this we just added our current word which is 100 and we just processed this also separately. So you could see the problem right here. So given a problem that could be broken into suffix part and then prefix part followed by the current word. So we'll just process the prefix followed by we'll add word and then we will process the suffix part. So let me explain you that here only. So just if my number or what is this? If my number is 0, I'll just return nothing but a 0 because that's my, I couldn't say it's as a base case, but that's my exceptional case because that's not yet defined over there. And now I'll just go through my number comma word in my map and I'll check if my current number is greater than or equal to num. Okay, if my current number is greater than or equal to num, or if I give number as 44, then first it will be processing this it's not greater than 44, so it won't be taking into consideration because 44 has nothing to do with 1 billion, and this also won't be processed, this also won't be processed. Finally it will be coming to here and it will be checking if 44 is greater than or equal to, sorry, if number is greater than or equal to num, in the sense that just I missed something over here. So here, instead of checking greater than or equal to, I should check the less than value, right? If my number is less than num, in that case only my 40 will be lesser than 44. In that case, it will be coming here and it will be processing this. Got my point? So until the number is greater than that number, we have nothing to do it. But soon we found a number that's lesser than the current number, then we have something to do that because here 40 would be lesser than 44. In that case, we'll just check the condition with this and we'll need to map it over here. And that's fine. Now we do have it. Now I'll just need to compute the prefix and suffix part. So how would I do this? Is fairly very simple. So now the fairly simple task over here maps to if my number is less than n, so I just reached to the 40 position and then you knew the prefix should be computed, or I'll just say you how we'll do that. If you found out a number to be 123, then you knew that it would be processing twice 123. But if my number is lesser than 99, then it would be simple. It is 90 and 9. So to you just found what I'm trying to say is if my number is greater than or equal to 123, then we would have two values to be mapped from this map to get our answer. So for prefix, we'll just check if our number or the current num by 100. Sorry, if my current num is greater than or equal to 100, then just we'll need to convert number to words of that num by 100, right? If it's not, then we'll just have a empty string of it, and my current word will be what word, or my current word is directly a word, so string I wouldn't do anything because it's already word, so no need to do anything. So string suffix would be if my person number is equals to 0, then it would be nothing, else it would be what, and this should be followed by, if my prefix is something there, then it should be followed by a space, and if my suffix is if my suffix is divisible by number, then no suffix would be there, else there would be suffix, that's map of num percent 100. So just got what I'm trying to do over here. So this is how it goes, but why are we using map here? We just need to convert this also into number of words, because this is recursion call. We already found our prefix, then we also need to convert this into number of words using that recursive function. So I'm not sure why I use map here. And it will be again num followed by, okay, fine, just let me try submitting this. So now what I'll return, prefix place, what's the current word of it, and then followed by suffix. Just to try running that up. I'm getting a runtime error. I'm not sure. Okay, I'm not sure if my current number is greater than or equal to 100. Why am I dividing it by 100? I should divide it by number, right? I should divide it by my current number so that I would get a proper prefix of it. I need to say if my number is given to be 10 or 100 billion, then I need to divide it by this number, not by 100, because then only I'll get a proper prefix, and then prefix followed by the current word, that's billion, and then after billion again processing will happen. So billion being the current word, the prefix of it would be the coefficient that's divisible by 1000 of it, not 100. So it would be number. I'm sorry for that. Here also it would be number, because after processing the current word, then for suffix we need to get the remainder of it, and that should be percent number. So now just let me try. Why am I getting 900,000 instead of putting 1 million? Okay, so just if we can, acha, got it. So if we just consider our example, if number is less than m, we are considering, but it could be equal to as well, right? If it's equal to as well, like in our case of 40, just we checked, if we give 40, then this element also won't be processed and it will be going to 30, but that should not be the case here. Either if it's equal, then also it should be processing. And yes, that's working fine of it. So just let me try to explain again what I done. Just we specify to our compiler that these are the possible mappings in our English words, and having iterating through all of them, I'm just checking if my current given number is greater than or equal to the number that's present over the map. If that's the case, then I'll just check if my number is greater than or equal to 100 as well. Why I'll check this condition is fairly simple. If my number is greater than or equal to 100, you could see that we do have a prefix followed by the current word, and there would be 100 here, followed by the suffix of it. So if my current number is less than or equal to 99, it's just 90 and 9. Just that would be coming within the suffix itself, because prefix and suffix would be differentiated by prefix, and then we need to have the current word. Here in this case is 100, in the case of 123, and followed by suffix. And in the suffix as well, there's a prefix 20 and then followed by 3. So we just will have in that condition where there is elements or the number is greater than 100. But if number is greater than, less than 100, then there won't be any such case of prefix solving for the current word and then suffix. So just for prefix, I'm just checking if my current word is greater than or equal to 100. Then I'll just keep my current word as it is, and just I'll compute the prefix of it. So for computing the prefix, again we would follow the same approach of converting number to words. And as this is prefix, this should be followed by a space. And if it's not greater than or equal to 100, then there won't be any prefix, so it's just an empty string. And for suffix, I'll just check if my number is divisible by num is divisible by number or not. If it's divisible, then there won't be any suffix. But if it's not divisible, then we need to convert that to number of words and followed by person number. Just you know that for formation, we'll just add a word to prefix and then followed by suffix. So just let me try submitting this out. Uh, we got an error. Mm, we were processing it as 12 billion 34 million, and it should be 1 billion 234 million. Uh, yes, yes. Just let me check it out. What's causing this error? Mm, maybe here. Letting right only. Number. Let's I'm just running it again. Okay, okay. So there should be other zero over here. Yes, yes. Sorry for that. Yes, it's working fine. We bet for 49% of the people. So as just requested, I'll just try to dry run this for 123 examples, my approach. So first, I do have this map. I'm not writing this again. Having my number as 123, so it's greater than, first it would be coming till this position, and once it's at this position, we'll find that our current number is less than or equal to num. So if it's less than or equal to num, if we'll just check if it's greater than or equal to 100. If it's greater than or equal to 100, then we do have three stages of it. First, for prefix computation. So just let me add this in the second row. So for the prefix computation, we'll be just having one to process separately, followed by our current word, that's 100, and followed by my suffix. What's the suffix over here? It's num percent number, then 123% 100 would be 23. So this is my condition, and now I'm at this position. So at this position, I'll just check if my num is less than or equal to num. In the same way, it will be iterating till the first or the last element of the map, that's 1. And for prefix, it will be checking if number is greater than or equal to 100. It's not, so just prefix will be empty. Followed by suffix. Suffix also 1%, 1 would be 0, so there won't be any suffix also. So directly word will be written over here. And what's the word over here? It's 1, and followed by this position. So for this recursive call, just I'll check it out like until my number is less than or equal to num. So it will be ending it at 20. And once I reach the 20, I'll just check if there would be any prefix or not. If my nums is greater than or equal to 100, there won't be any prefix, and my current word is 20, and followed by my current word is already added, so just I need to process the prefix of it. Sorry, prefix is not there, I just need to process the suffix of it, that's 3. And again we are here 1. I won't write it again here. So just we left at this 3 number, and this 3 is also greater than or equal to 3. There won't be any prefix and suffix in that case, and we'll just return the word. So as our recursive calls proceeded, we found out the value in this way, 123. So our final answer would be 123. So got it. So this is how dry running of this will works. Thank you. Please feel free to add anything if you feel anything is unclear. I'll try to explain that part again. Thank you.